Hey guys, this will be a video for the Unit 5 Progress Check B. Alright, so reading along, I have the first one as a calculator required question, and it says the concentration of a certain element in the water supply of a town is modeled by the function f, where f of t is measured in parts per billion and t is measured in years. The first derivative of f is given by f prime of t. So yeah, f prime of t is equal to 1 minus the natural log of t minus sine of t. Okay, at what times t for 0 to 5 does the concentration attain a local minimum? So let's just go ahead and graph this. So this is f prime that we're graphing. So if we graph this, so we got 1 minus the natural log of x, and then minus sine of x. And the window I'm going to set from 0 to 5. I'm going to graph that. And so we're trying to look where the concentration attains a local minimum. And so a local minimum will occur when f prime changes from negative to positive. And so I can see that that's happening around that point right there. This would be a local maximum. So I want to figure out what the x value is here. So let's go to the 0 option, do a left bound marker, do a right bound marker, and I got that x is equal to 3.52. So x equals 3 point, or I guess I should say t. So t is equal to 3.5, what was it? 3.352, so 3.352. That's where it obtains a minimum because it changes from negative to positive there. And so looking at the options, looks like it's got to be C. Yeah. So for 2, let f be the function with the first derivative. At what values of x does f have a relative maximum? So this is f prime of x. F prime of x is equal to x plus 1. And then we have x minus 2, and we have x minus 3. And so at x, so f prime is going to be equal 0 at x equals negative 1, and at x equals 2, and at x equals 3. So using the first derivative test, we're going to make a quick number line here. So we got negative 1, we've got 2, and we've got 3. Not to scale in any way, but if you want to, we're going to test values in between here. And so I like to test 0 because that's just an easy one to test. So if I plug in 0, that's going to become 1, this is going to become negative 2, this is going to become negative 3, and all of that multiplied together is going to be positive. So so f prime is going to be positive here. So we can plug in negative 2. So negative 2 would make this negative. So I'm just going to, I'll keep track. So this is going to be negative. If I plug in negative 2 here, that's going to make it negative. If I plug in negative 2 here, still negative. So altogether, f prime will be negative to the left of negative 1. We can plug in 2.5. So if I plug in 2.5 here, that's going to be positive. If I plug in 2.5 here, that's going to be positive. Plug in 2.5 here, that's going to be negative. So altogether, it's going to be negative. And then if I plug in 4, so 4 is going to make this positive. 4 is going to make that positive. That's going to make that positive. So it's going to be positive here. And so the graph is going to be negative, then positive, then decreasing, then increasing. And we're trying to see at what values of x does f obtain a relative maximum. So that is at x equals 2. at x equals 2 only, so that's going to be A. So for 3, the graph of f prime, the derivative of f is shown above from -1 to 5. Which of the following statements is true from -1 to 5? So the graph of f prime, the derivative of f is shown. Okay. So f has 1 relative minimum and 2 relative maximum. So this is the graph of f prime. So let me just go ahead and make a quick kind of number line here. So at x equals 0 has a critical point. At x equals 1 also has a critical point. At x equals 2, critical point. X equals 3, critical point. X equals 4, critical point. Okay, now f prime is negative, and then it gets 0, but then it's still negative, and then from 1 to 2 it's positive, from 2 to 3 it's negative, from 3 to 4 still negative, 4 onward is positive. And so f has 1 relative, let's see right here. So f prime, so the graph of f is going to be negative, 0, then negative again, then positive, then negative some more, and then positive. So I see for maximums, I only see 1 maximum, and I see 2 minimums. So 1 max and 2 minimums. So A, f has 1 relative minimum. No. B, f has 2 relative minimum. Yes. And 1 relative maximum. Yeah. So that's B. Just to make sure, so C, f has 2 relative minimum. Yes. And 3 relative maximum. No. D, f has 3 relative minimum. No. 3 relative maximum. No. So yeah, it's got to be B. So the fourth question. So we have let f be a function given there. So we have f of x is equal to negative x to the third plus 3x squared plus 24x. What is the absolute maximum value of f on the closed interval from -6 to 6? So we're using the candidates test, and we are going to find the derivative to find our critical point. So f prime of x is negative 3x squared plus 6x plus 24. I'm going to factor out a negative 3. I'm going to get x squared minus 2x minus 8. And then that can factor. That's going to become x minus 4 and x plus 2. So that means x will be equal to 4 and x will be equal to negative 2. All right, so make a table of x values that I have, and the x values are going to consist of our endpoints, which are negative 6 and 6, and then our critical points, which will be negative 2 and 4. So, and then we have f of x, of course. So we're just going to plug these values all into this function right here. And I'm sorry, I'm just not going to do that by hand. Sorry, but not sorry. I'm just going to plug these in. So, got negative x raised to the third power. We got plus 3x squared plus 24x. So I've got 180 here. I don't think it's worth checking the rest, because that is the largest value so far, and that is the largest value in our answers. But I mean, heck, for the sake of answering it, doing the work, so if I plug in negative 2, I get negative 28. Let's say I plug in 4, I get 80, and if I plug in 6, I get 36. So obviously my maximum value on this interval is going to be 180. So this is the max, and that's going to be D. All right, for the fifth question, let f be the function defined. So we got f of x is equal to x to the third minus 3/2 x squared minus 6x. What is the absolute maximum value of f on the interval from -2 to 3? So let's find f prime, which is going to be 3x squared minus 3x minus 6. I can factor out a 3. I'll get x squared minus x minus 2. I'll get x minus 2 and x plus 1. So I have x equals 2 and -1. We're operating on the interval from -2, or from -2 to 3, yeah. So if I make a table for the candidates test, we got x, we got f of x. So we got our left endpoint, which is -2. We've got -1, 2, and we've got 3. So I'm going to plug these values into my function. Again, I'm just using my calculator. So x to the third minus 3/2 x squared minus 6x. And I got -2 for that. Okay, let's use -1. And I get 3.5. They're using fractions, so that's going to be 7/2. Let's do 2 stores x. And I've got -10. Let's do 3. We're going to plug that in. And I got -4.5, so -9/2. And we're looking for the maximum value, so that's going to be at -1, that's going to be 7/2, so we got the max here, so that's going to be C. And then last but not least, we have question 6. So we have let f of x equal x times by cosine of x minus sine of x. What is the absolute maximum on the candidates test? So let's find f prime. So f prime of x is going to be equal to, I'm going to need to use the product rule, so it's going to be first times negative sine of x, then plus the derivative of the first times by the second, and then minus cosine of x. And we're going to set that equal to 0. I'm going to factor that, so I'm going to take out a, hold up. Did I do this right? So I did the first times the derivative of the second, plus the derivative of the first times by the second, and then minus cosine. Oh, wait a minute. Those cancel. Okay. So we get f prime of x is equal to -x times by sine of x. Set that equal to 0. Now that will be equal to x when x equals 0, or when sine of x equals 0, which will be when x is equal to 0, and at pi, I would say negative pi, but that's not going to be an interval, so 0, pi, and 2 pi. Okay, and so these are the critical points happening here, and then we have our interval, which is from -pi/2 to 2 pi. So using the candidates test, we get f of x. So we have the left endpoint, which is -pi/2. And then we are going to plug in 0, pi, and 2 pi. And I'm going to set a good example. I'm not going to use my calculator when I'm using these ones right here. Okay. So we're going to plug these into our derivative. Let's do, so we're going to do f of -pi/2, which is going to be -pi/2 times by cosine of -pi/2 minus sine of -pi/2, which will be equal to -pi/2 pi over 2, negative pi over 2 is the angle that goes down. And so that's on the negative y-axis, and cosine is associated with the x, so that's just going to be 0 minus sine of negative pi is going to be negative 1. So this is going to be equal to 1. Okay, f of 0 is going to be equal to 0 cosine of 0 minus sine of 0, which is all just going to be 0. Okay, let's do f of pi, which is going to be equal to pi times by cosine of pi minus sine of pi. So that's going to be equal to pi. Cosine of pi is negative 1. Sine of pi is 0. So this is going to be equal to negative pi. So negative pi. Okay, and then we have f of 2 pi, which is going to be equal to pi times by cosine. I'm going to give myself a little bit more space. I'll move this over here. So pi times by cosine of 2 pi minus sine of 2 pi. And sine of 2 pi is 0. And so this is going to be pi times by cosine of 2 pi is 1. So that's going to be equal to pi. I'm going to check these right here. Need to check my work. So, f of x is equal to x cosine of x minus sine. The derivative is going to be the first times by the derivative of cosine, and the derivative of cosine is negative sine. So negative sine of x, negative sine of x. So I do the first times the derivative of second plus the derivative of the first, which would be 1 times by the second, so cosine, minus, and then the derivative of sine is cosine, so minus cosine. So I get those cancel with each other. So I get f prime of x, and the f prime of x is going to be equal to, it's going to be equal to negative, okay. I don't think there's anything wrong with my derivatives, and I set that equal to 0, so that's when x is equal to 0, or sine of x is equal to 0, and sine of x is equal to 0 at 0 pi and 2 pi. Okay, so I think I got all that. Well, that's fine. Okay. So that's going to be 1. Okay. Oh, what the heck? Sorry. For 2 pi, I plugged in pi, not 2 pi. So f of 2 pi is going to be equal to 2 pi, there we go, times by cosine of 2 pi minus sine of 2 pi. So that's going to be equal to 2 pi times by 1 minus 0, which is going to be equal to 2 pi. That's equal to 2 pi. Okay, and the question is asking for what is the absolute maximum value of f. That's going to be at 2 pi. So, yeah, so that's got to be B. Okay. All right, and that's everything for this progress check.